Okay. Hello everyone, my name's Katja. I'm going to be your moderator for the session Uncrossing Planetary Boundaries, how to get nutrient flows back within safe ecological limits. I'm very, very honored to be here today. It's an exciting topic. I'm very excited to be able to discuss this with all of you. And I'd like to welcome our guest speakers today. I would like to welcome John, the director of DG R&I, who is sitting right next to me. Then I'd like to welcome our speakers that are connected remotely today. Professor Mark Sutton, who's a research director at the UK Centre for Ecology and Hydrology. Very, very great to have you here today, Mark. Then we have Chiara Manoli, Vice President at ECOFI, the European Consortium for Organic-Based Fertilizers Industry. And finally, we have Yannis Mas, the President of the European Young Farmers Council. Welcome to you all. So, I'd also like to welcome, of course, everyone who is watching us today. I forgot that. We're going to have a session today. Every one of our speakers is going to give us a quick statement, then we're moving into a panel debate. I'll remind you that we only have 45 minutes today, so we need to be quick and concise. And if you, who's watching today, if anyone has a question, you have a question and answer button, I think, below your video. Don't hesitate to use it and let us know if you have a question to one of the speakers. John, would you like to introduce us in our topic today?
Great, thanks, Katja. Thank you very much. And good morning, everybody out there. So we're here to talk about how do we get our planet back on track. We know now that planets have boundaries and limits. Our Earth is reaching and overreaching its limits. And our century's great task for science and society alike is to realign our biosphere, our economy and our society, to restore our life support system so that it will continue to provide our life support systems of water and air, soil, biodiversity, ecosystems and basic things like food. The European Union, as you know, is having this new moment where we're talking about having a Green Deal mission. How can we actually get to develop a healthy planet that is climate neutral by 2050 and that works within these planetary boundaries? And the planetary boundaries developed by Johan Rockström tell us all about the fact that we have severe global threats that are beyond just climate change and asking us to set priorities on how we're going to move from aspiration to realization. How are we going to sustainably manage the planet's resources and preserve them for future generations? How are we going to live within our planetary means? So our discussion today is a very focused look at one area where we've already overshot our limits. We're looking particularly at excessive reactive nitrogen and phosphorus flows into our biosphere. And we need to imagine systemic changes to address this. And science and society, practitioners and thinkers have to work together now to make this change happen. At the heart of our Green Deal is an ambitious systematic change to all of the policies that can shape this direction across environment, industrial waste, agriculture and the bioeconomy. There are new policies being rolled out, a zero pollution ambition, a radical biodiversity strategy for 2030, a farm to fork strategy, the first major policy on the food system in probably a generation, where there are targets to cut fertilizer use by at least 20% and reduce nutrient emissions by at least half by 2030. Hugely ambitious ideas. We have a new circular economy action plan and an integrated nutrient management action plan. And we've also got a very ambitious moonshot mission on recovering the soil so that it's healthy and sustainable for our food systems. So with all of this, we need to get down to some very practical navigation here. How are we going to do this? Our planetary boundaries for nitrogen and phosphorus are already exceeded. Emissions are everywhere. Soil is polluted, as is water and air. There's a major knock-on effect on biodiversity and on greenhouse gas emissions. So we need to address things systemically and urgently. And we need to ask research and innovation to step in and step up to try and set direction in tackling these issues holistically across all of the different aspects of the planetary boundaries that need to be addressed, and to start where everything begins and ends, which is where people live and work at regional level, developing regional loads targets approach for both of these emissions, and maybe looking at budgets for nitrogen and phosphorus from various sources. And we need to look at the local conditions and what the local actors can do in setting this together. So how do we get ourselves back on track, and how do we look at this whole issue of our limits here within the context of this great ambition that we have, this opportunity we have to restore our systems? I'm delighted to hand over now, with a 1.5 second delay, I think, to Professor Mark Sutton, who, as Katya said, is one of our leading thinkers and scientists at the UK Centre for Ecology and Hydrology. Mark, over to you.
Yes, thank you very much, John. And can you hear me?
Yes.
Excellent. Well, let's get the slides up on the screen, and you tell me if you can see the slides.
Yes, we see the slides.
Excellent. Thank you very much. So uncrossing planetary boundaries, that's our challenge, how to get nutrient flows back within safe ecological limits. And I'm speaking from a UN perspective, from a UNEC perspective, from an EU perspective, from all these different perspectives linking up. And that's our challenge indeed with nutrients, how to link things up. So let's just step back. A few years ago, we produced the European Nitrogen Assessment. And shortly after that, we produced the Our Nutrient World Report. And I think the first question we have is, what is the big idea here? Is it nitrogen? Is it phosphorus? Is it nutrients? I would say it's all of them. We've got to learn to have a public conversation about these things. And clearly, we've not having a public conversation enough. You can have climate everywhere, climate with your breakfast cereals nowadays. But nitrogen, phosphorus, nutrients are not getting the visibility we need, and we need to find out why. So nitrogen is appealing to people who like joining up. Phosphorus, I would say, particularly water system people, say it's forgotten. And of course, nutrients is all together. So what are we doing to our planet? And here's an image, I think, that might resonate. Force feeding the planet. So not just force feeding ourselves too much, but we've mobilized all of these nitrogen phosphorus flows around the planet, digging up the phosphorus out of the ground, capturing N2 from the atmosphere, making it into ammonia and nitrate, different nitrogen forms, and ending up making food, but also saturating ecosystems across the planet. So our planet really is under big pressure from nitrogen and phosphorus. We need to take action. So let's just look at these planetary boundaries, which we're so familiar with. I think it was a shock for many people to realize that of the most exceeding boundaries, phosphorus and nitrogen are right out there. You can see them down at the bottom left, way beyond the range of uncertainty. It doesn't mean that climate change is unimportant, but it's highlighting a message that we'd forgotten these nitrogen phosphorus pollutants. So if we look at the system, I would say that public and policy action had been much less than their importance requires. There's absolutely no doubt about that. And if you look at it with the Green Deal coming up, this is excellent. This is now beginning to take these issues seriously. I've plotted actually the Green Deal sitting on the zone of uncertainty or beyond uncertainty. It's great that the Green Deal is being talked about. Remember, so far this is a strategy, not yet policy commitment implementation. That is, of course, for the member states to agree how to move forward. Will it become reality that these issues are addressed? So let's look at the flows across the system, starting on the top left with unreactive nitrogen in air and phosphate rock on the left. And our intended flows are to make fertilizers, also to grab nitrogen out the atmosphere in biological nitrogen fixation, to feed crops, getting crops to grow, to feed animals, to feed ourselves, and add into that also detergents and other products. So those blue lines indicate what we planned to do on the planet. But now look at the other flows. The first is that high temperature combustion converts N2 in the atmosphere into NOx, nitrogen oxides, air pollutants. So it's an unintended major nitrogen flow. And then as we come out of the crop system, we've got nitrous oxide, greenhouse gas, nitrogen oxides again out of soils, ammonia, and then things going down the rivers and into the seas in sewage, water, nitrate, phosphorus. The system gets more complicated when we have further emissions from the livestock system, and then we start reacting different parts of the system, the ammonium and nitrate coming together, coming down onto forests, saturating the nitrogen supplies of our ecosystems. That leads then to the ecosystems themselves releasing nitrogen back to the atmosphere, becoming saturated, until finally, in this cascade, at the end of it, we see the N2 emission coming off as the N2 is converted back to atmospheric nitrogen forms. But on the way, it's had all those different flows, and linked to all those different flows, all these different effects. So you can say that nitrogen and phosphorus are changing multiple systems. It's systemic on our planet. All the concerns we know so well, from stratospheric ozone loss, air pollution, particulate matter, the greenhouse gas balance, water pollution, they're all linked to disturbance of nutrient flows. So let's go forward and simplify this down. Why nitrogen? I've highlighted 5 reasons there: air quality, climate, water quality, biodiversity, soil quality. All of those have got costs. We'll add into that it's not just costs for the planet, but as a resource across planet Earth, something like $200 billion a year worth of nitrogen cash cost wasted. If you were to buy fertilizer on the farm gate, but say we've lost that to the environment, it's a waste of 200 billion. So this is a huge resource challenge. We're working together on a global scale with the United Nations Environment Programme, with the Global Environment Facility, towards something called the International Nitrogen Management System. We realize we've got to be joined up and work together. And the next step from that basis, which is a scientific activity to support policy, is to go towards a new global intergovernmental policy process, the Interconvention Nitrogen Coordination Mechanism, or INCOM for short. There was not ambition at this time for a new convention. People say we've got enough conventions, but we need all those existing conventions to work together and take this really seriously. So let's go forward to the looking at what is happening, some of the steps globally. And UNEP, for starters, has launched a global campaign on sustainable nitrogen management. There's also a global partnership on nutrient management, and different parts of this coming together. So the first is that the United Nations Environment Assembly has made a first ever resolution on nitrogen. There it is, UNEP EA4 Res 14, adopted last March at the last Environment Assembly, the highest level decision-making body on the environment of planet Earth. So it's now beginning to be taken seriously with action. The next step is this goal. We've agreed a goal in several fora to halve nitrogen waste by 2030 to save $100 billion a year. Half of that 200 billion, how to save it, reduce pollution. Different elements of that. So the first is, imagine the Sustainable Development Goals. All of those 17 Sustainable Development Goals, you can see there's a reason for taking action on nitrogen, whether it's food and poverty or education. There's gender issues in relation to nitrogen management, air, biodiversity, water, and of course, number 17 is partnerships for the goals. We must have everybody working together on these kind of challenges. In terms of the details, the International Nitrogen Initiative made a commitment in 2018 at the Our Ocean Conference in Bali, and that was rapidly followed up by the Colombo Declaration in 2019, where 14 UN member states agreed to have the ambition to halve nitrogen waste by 2030. So that's a real step forward. It's going beyond the resolution, which just says we should take this seriously, take action, but doesn't set goals. I'm very excited to see the EU Farm to Fork strategy framing the halve nutrient pollution. Well, whether you're halving nitrogen waste or halving nutrient pollution, it's amounting to much the same thing. And also, of course, the EU biodiversity strategy. So things are moving forward. And of course, we should also not forget about the phosphorus, the potassium, the micronutrients. They rather get less conversation. But let's say when we eat a meal, think about that burger. You don't eat it all in one go. It's bite by bite. So the nitrogen is an illustration of joining up. We're not forgetting the phosphorus. We must also think about all the other sources. And we must have a public conversation about how to do this where everybody can engage. So let's just look at the flows. This is the European nitrogen flows. And what is blue is the intended flows. Of course, fertilizers is the big one. In Europe, less nitrogen from biological nitrogen fixation. These are in millions of tons, by the way, the units where you see a number, millions of tons of nitrogen. And out of these, there's several key messages. All of those different nitrogen forms are, of course, a loss of nitrogen. They're also having pollution effects. The first way we tried to value this was the hard way. Try to add up all the climate costs, the water costs, the ecosystem costs of this. We got a number of between 70 billion euro to 320 billion euro per year in the European nitrogen assessment. Now, interestingly, the policymakers came back and said, well, do we really care about this? Because who is paying those costs? Well, society is paying those costs. Message was, for example, we want more the farmers to how can they benefit? So let's look at the next part. The next bullet is about the costs to the actual cash costs. So here we are. And if we can go down to 25 billion euro of nitrogen lost annually per year. This is the farm gate cost, total nitrogen losses. And of the food system, something like 20 billion euro. Now look at the cost of the Common Agricultural Policy. It's running at something like 57 billion euro per year, which means that a third of the cost of CAP is lost in nitrogen pollution alone. Now, I would say, though the CAP negotiations spend a third of their time talking about nitrogen loss, well, of course, you know the answer. Of course, they don't. They talk about a million other things. The message here is nitrogen, phosphorus, nutrient pollution must be at the heart of these discussions. Now, on those flows, that diagram, you can see various green buttons, and I'm going to come up with a bit more buttons on the next slide, where you'll be able to see what we need to do about it. Just to say, before we do that, the Green Deal, of course, is thinking about how it can become financially viable to manage nitrogen better. And I would say in that, we must also think about the COVID recovery. What is the connection of COVID recovery of nutrient pollution? Well, the number one issue is there's opportunities to be more financially viable by not wasting all of this nitrogen resource. So as we recover, this must be at the heart of our activities to be more profitable in future. So how are we going to get there? If we look at this next slide, I've put in there on the left the different nutrient resources: nitrogen, phosphorus, fertilizer, manure, unintended nitrogen fixation. And the arrows going to the right are each of the major nitrogen flows. The biggest nitrogen flow is the nitrogen for feed crops, not for food crops, but for feeding livestock. We've got the livestock themselves, the food crops, the food supply chain, our desire to eat. And then, of course, the return flows are the nitrogen in sewage, the nitrogen manures. Each of those has a green button because it's where we can take action, managing our sewage better, our manures better. And I would say the number one issue is we should not focus on denitrification. That means converting nitrogen resource to atmospheric nitrogen. That's a waste. A wastewater treatment plant goes around costing money but wasting resource unless the nitrogen and phosphorus are being recovered. The next part is the motor of that system, which is the food combustion diet choices. Our work has shown that European citizens are eating much too much meat and dairy compared to our needs. There's an opportunity to optimize the system, have a better, healthier diet, and reduce pollution at the same time. To the slides on the bottom, input by combustion, our driving for food and energy. The key message there is that green line at the bottom. There's an opportunity to learn how to recover that nitrogen, stick it in a bag and sell it, and we're not there yet. So let's think of the parts here of this system. And the first is that all sectors need to contribute. The second is that investment is needed. We're not going to get there just by coasting in, because many of the actions take money in order to implement them. If you think about climate action has not happened by chance. It's happened because of targeted, focused investment, knowing we've got to do something about this. And of course, in doing something about this, there's opportunities. And here we are, a few buzzwords: nitrofinance and phosphfinance, and have nutrifinance as well. So there's whole new words there out there. And if we think about the EU green finance taxonomy, I don't think these words possibly exist yet. They need to exist, because if we're going to change, we need investment in this, just like we've had investment in the climate challenge. Going forwards, of course, as I've said, this is critical that CAP reform, COVID recovery need these issues right at the very heart. So how are we going to do that? I want to put solutions in context, and I see that we have Yanis and Chiara speaking in a moment, and I've got a little bit for you here in thinking about this to realize that different people are coming from different places. On the graph on the right, there's potential benefit and there's potential cost. So cost to stakeholder or end holder, if you're a stakeholder, let's think about it as nitrogen as well, and a net benefit. So let's put a line on this and see that at the moment, there's current losses, those 20 billion euro per year in the EU from the food system. Taking action means that there's, first of all, low-hanging fruit and an opportunity to make a profit. Of course, the question is how far to go. And if you really want to go far, there's going to be a cost for the end holder. So let's think about that. A farmer that's taken no action whatsoever, taking action with investment offers low-hanging fruit, an opportunity to be more efficient, save money. Now, of course, you may have farmers in a really sensitive context. Some of the situations in the Netherlands are sensitive. They may have to go further to protect the environment, justified by wider societal ambition. So let's go down onto the next part of this slide, which is just to think about innovation. The more we innovate, the more we can make the benefits bigger and the costs smaller. That, I think, is pretty clear, and that matches to the climate situation. The nitrogen crisis, as Yanis may tell us more about the nitrogen crisis in the Netherlands, where they're talking about reducing animal numbers. There's already been massive constraints. The motorways, you can drive slower on the motorway now because of NOx pollution. That nitrogen crisis is not just a Netherlands issue. It's a Europe-wide issue. It comes out of the Habitats Directive, the need to protect our habitats. So how are we going to deal with that? The next issue coming down on this is that there's lessons from and for organic farmers. Now, often we get the message that if there's organic farming, there's no issue at all. Well, I would say the first off is that an organic farmer has got an even bigger motivation not to have pollution, because that's the nutrient resource the farmer needs in their system, because they're not going to be using fertilizer. And the second thing to say is that everybody needs a manure cover. If you're whether you're an organic farmer or a farmer using fertilizer, your cow still makes manure. That manure, think of it, put a lid on the manure tank. Does every farmer in Europe have a lid on their manure tank? Well, of course not. Everyone does, whether organic or not. So there are lessons really for everybody. Now, coming to the end, what you will have seen is I haven't talked much about the research needs. We maybe take that a bit more in the discussion. But out of this conversation, you can see there clearly is a need for research. Optimizing flows to reduce impacts, that is a challenge. The solutions evaluation, all those buttons I showed you, each of those need to be evaluated. The hard numbers, and by hard numbers, I don't just mean the cash. Clearly, we've got to show how to make it profitable. But I also mean the hard numbers. If you think about phosphorus stocks in soils, that's a hard number to work out how much to get into the soil, back out of the soil, because the soil stores phosphorus in a quite hard way. If you think about nitrogen, there's some tough numbers there. The conversion of nitrate to N2, the denitrification, is very poorly known, and it's very complex to control in natural systems. And lastly, right at the end there, we can see that we've got to think about societal transformation. How are we going to get there? So with that, I'm going to hand back to you, Katja and John, in the studio. Thank you.
Thank you, Mark. That was excellent. Well, it was also very alarming. We are certainly aware now that we're dealing with a massive, massive challenge. Now, I'm very curious what Chiara will tell us. She might have part of the solution. We'll see what she will tell us about organic-based fertilizers. Chiara, the floor is yours.
Yes, thanks, Katja. Can you hear me?
Yes, go ahead.
Okay. Good afternoon. Thanks for inviting me as a speaker at this session of R&D Days. I'm Chiara Manoli, Regulatory Affairs Manager of IRSA, an Italian company producing organic-based fertilizers. And today it's a pleasure for me to be here as Vice President of ECOFI, the European consortium representing producer of organic and organomineral fertilizers and organic soil improvers. First of all, I would like to try to make some clarification about the use of the term organic, because it may be used in different contexts with different meanings. But in the organic-based fertilizers, the term is used in the chemistry sense. Indeed, it means that contains carbon. Indeed, all the organic-based fertilizers add organic matter and therefore carbon to soils. And it means that this fosters biodiversity in soil and improves soil structure and water retention. And also the organic-based fertilizers enrich and revise soils to ensure their fertility and the sustainability of the agricultural production. Even if most of the organic-based fertilizers are used in organic farming, not all the organic fertilizers are allowed in organic farming. Then it's important not to confuse the terms. When we talk about organic-based fertilizers, we don't have to think only about unprocessed manure, compost, etc. Indeed, even if the historical production in Europe of these fertilizers derives from the reuse of discarded materials from other value chains, today the industry of organic-based fertilizers produce very innovative fertilizers with a consistent quality and safety, thanks to the standardization of the productive process. And just to make some examples of discarded materials used to produce organic-based fertilizers, I mention the residuals of resins from wine making, the scraps of hides and skins from after tanning, the chicken litter from egg production, fish meal after the removal of the fillet. They are just some examples. For farmers, the use of organic-based fertilizers may represent a good tool in the current challenges of the European agriculture. Indeed, they provide organic sources of nutrients with a consistent formulation and reliable nutrient content. And also the producer may guarantee the traceability of raw materials used. And this differentiates them from the raw menus, for example, which has a variable nutrient content and may also contain some impurities. And furthermore, their circular economy is well represented in the organic-based fertilizers, because they may represent an important tool in the Europeans' new policies objective for a transition towards a more resilient, sustainable and carbon neutral food chain. So going on to the PowerPoint, the slide. the organic-based fertilizers may be therefore be used to reduce the nutrient load by recycling nutrients which would otherwise be discarded, and delivering consistent product formulation to ensure balanced plant nutrition thanks to an improvement of nutrient use efficiency and a reduction of nutrient losses, and allowing plants to take up nutrients when the plants needs these nutrients, thanks to the controlled release properties of the organic fraction in the formulation of the fertilizers. Today in Europe we have a regulation that includes both inorganic and organic-based fertilizers, and for our sector it is an historic milestone. However, in order to maximize the benefits and the contribution of these products, we need more coherent policy and regulation. I would like to provide just 3 examples that you may see in the slide on the screen. The first one is that at the moment, the Nitrates Directive doesn't distinguish between unprocessed manures and organic-based fertilizers, but they perform very differently in the field. Another example is that organomineral fertilizers combine availability of mineral fertilizers with the qualities of organic matter and control the nutrients release. Another example is that nutrients from organic sources like a waste stream can be precipitated into products with similar properties to mineral fertilizers. Then the organic agriculture is unlikely to be a channel for widespread nutrient recycling due to some restriction. For example, it was rejected the factory farming manures, and currently some not mineralized nutrients from organic sources are excluded, such as wastewater deriving from cities.
Chiara, can I quickly interrupt you? We really have to speed up, so if you can give us your last thoughts before I change to Yannis. Thank you.
Okay. Yes, and then another challenge is to have endpoints from for the Waste Framework Directive and the Animal Byproducts Regulation. So what we suggest as inputs to overcome these challenges and to promote the use of organic-based fertilizers to farmers is that it should be very important to that farmers know well these products because at the moment farmers are not don't want to pay the same price that they currently paid for mineral fertilizers for an organic-based fertilizers. And then we think that farmers requires more incentivation and access to improved products, information and training in integrated plant nutrition and soil fertility management. And then we suggest, yes, to make more formation because sometimes it is difficult to use these modern and research-based organic-based fertilizers, and then see the positive effects for farmers. Thanks.
All right, great. Thank you, Chiara. That was very, very, very interesting. And I think Yannis already heard his cue. What do farmers think about? And I think you're going to show us a picture of your own farm. How do you deal with nutrients, with nitrogen and phosphorus emissions? The floor is yours.
Thank you. Well, first of all, let me also express my gratitude for the invitation and the fact to be speaking alongside such an estimate panel of experts. Maybe if I can point out a few things that Professor Sutton also mentioned, and which I absolutely want to support, is that the widespread debate around nutrients is indeed lacking today, except around the breakfast tables of a lot of farmers, I would say. Across, certainly in some regions in Europe and in some sectors, farmers are debating this, whether it is from a very practical approach towards their farm management, or whether it is because of the overall challenges which have been mentioned by the professor. In that regard, I would say one of the final points that Professor Sutton pointed out is the most relevant for us. We have to look at, okay, what can we do at farm level to help us tackle these challenges, which are absolutely there from both an environmental point of view, but also an income point of view for farmers. What we are discussing are nutrients which are not only valuable, but very often rather expensive. So how can we deal with that? And then we think innovation is absolutely key there. However, innovation has 3 pillars or 3 steps. That is research, development, and it is very good that those elements are provided with enough attention, with enough funding as well. But all of that becomes useless if it's not followed up by the implementing factor. How can we make sure that everything which is designed, that every thought process, knowledge which is gathered, is also implementable and is actually taken on board by farmers, and in that sense, knowledge, agronomy is crucial, and that even though it is knowledge which is very often already there traditionally, but which must be combined with new ways of thinking, with new realization, with new data, the chance that we have via smart farming of really reacting on what is happening almost life is crucially to be available. And then obviously implementation also means making sure that best practices, available techniques which are there already today, are broadly taken on board. And for that, certainly from a young farmer's point of view, the main challenge remains funding. It is the capacity of investing at farm level. And I don't know if the picture that I provided can be shown. But there you see a bit the picture of our farm. And so obviously my focus in the picture is on the grass in front of it, which needed a bit of nitrogen, as you can see, a bit too yellow. This is a spring picture, so where the majority of our grass needs to be produced in that time, and that grass, just to remind ourselves for why we are actually providing nutrients to our crops. Well, that grass becomes the feed for our animals. We produce milk on the farm, and that feed needs to provide then for human feed. And so in that sense, we know that in the whole discussion politically and probably across society, food security is often being a bit waged, whether we still need that in Europe, whether that is not already an objective that we have reached. And without going into the debate on total yields, it's not only about producing food, it's also on producing particular kinds of food. And so for this, grass is my main input of protein for my cows. If I can't provide those protein via my own grass, and that protein production relates directly with the availability of nitrogen in its growth period, well, then I will be searching for sources of protein elsewhere, which, let's be fair, today would be soya coming from another part of the world, which is also debatable whether that is the good alternative. So we have to keep on picturing in front of us, okay, what are we actually doing and why are we doing that? But when we are talking about nutrients, on the picture, the grass isn't the only part where nutrients play a role, and Professor Sutton pointed it out. What happens 365 days within this table is as crucial, because our cows emit nitrogen throughout their life, throughout the day. And that also can have an effect on whether it is a nature area, which you can see on the left-hand side of the farm, or whether it is the farming area around it. And so also there, we have a responsibility as farming sector to ensure that the challenges which that brings to certainly particular kinds of nature can also be solved in our best interest. But for that, again, an era of investment will be crucial, because as young farmers, for sure, but farmers in general, that is an investment capacity which on today we do not have. When we are talking about nutrients from a more positive point of view of what they actually mean, and again, Professor Sutton mentioned it during his opening presentation, at the end, it is feed for our crop. And so whether those are crop residues of last year, whether those are provided by manure or other organic fertilizers, or whether they are provided by adding chemical fertilizers, the intent is how to provide nutrients for our crops in the best way possible, in the best timing, in the best circumstances. And the more knowledge we can get towards our farmers to make that decision, the more the policy framework should also offer a certain flexibility, so that farmers with that knowledge can also react on things which are changing. And today it feels for the farming community a bit difficult that increasing your level of knowledge in your management, or investing in best available techniques in terms of application of fertilizer, it doesn't really bring that much added value except for the environment, because at the end you are still way too limited by the policy framework which is designed, and which was designed with good intent. I'm not questioning that. But the more knowledge we are able to bring to the fields, the more precision we are able to bring in our way of application, the more flexibility should also offer to farmers to do best within the circumstances, whether they are weather circumstances, whether they are circumstances.
Sorry, we're really running behind time here. Thank you very much. This was very exciting. We took the message that finance and investment is a big problem. Now, John, we are the policymakers. You are representing the policymaker today. Is there anything we can do to address nutrient pollution in a very short answer?
Very short answer, yes. We need to build the knowledge. We need to, as Yanis has said, move from ideas to innovation to deployment. And as both Mark and Chiara have said, we need to make it accessible and available to everybody through dissemination. So I think in Horizon Europe you will see, through the mission on soil, an opportunity for lighthouse projects, for large-scale investments in testing these things at systemic level, and in feeding back into a regulatory system that needs both to drive the changes that we're talking about and to allow a certain degree of integrity to the people who are trying to make things happen in the different parts of Europe. So I think research and innovation, you will see, will move much more into the space, not just of generating the knowledge, but of trying to link up with the policies to deploy it, and then the investment instruments to scale it up. I think that's what you'll see next. But I would look particularly at the missions. You'll see some of the discussions today. Kees Veerman and the mission on soil, Pascal Lamy and the mission on the water system. I think they're big new platforms to make these things happen. Thank you, John. Mark, do you have a very final message for us? We have a bit more than a minute left. What would you give our audience? What message would you give to us for today?
Yeah, thank you. Well, I think the first thing is we need to be aware of nutrients. It shouldn't be just talked about on the farmer's table in the morning. It should be talked about on everybody's table. It's hard because it's hard to hate nutrients. And so why do you really want to take action? But once you see how out of balance is the world, we need to do it. It's great to see the soil mission. It's great to see the water mission. My question would be, how are we going to get the air and the climate, the water, the soil, biodiversity all linked together, and the nutrients give us an opportunity to do that?
All right. Thank you, Mark. We're working on it. Thank you, Chiara. Thank you, Yannis, for having been here today. Thank you, John. Have a great afternoon and enjoy the European RDI days. Thank you.